Drop it. All right, so if you want to kind of track any of this stuff, like 85, 86, maybe 87 is where some of this stuff is going to be. Again, I might have it written a little differently, even though we're talking about the same thing here. Starting with how to identify if something's a polygon. I didn't pull it from the book, so I don't know what the heck it says in there. But I'll have you, I'll have my testing, like how you actually decide if something is a polygon. I'll have it formally, and then we'll just talk about it like in general, what you should look for to determine if something is a polygon. Okay? All right, so that little thing, that might have been the first thing that was in there. I think that's why I put that up there, because they asked you what poly meant and what gon meant. It just means many sides. Okay? Has to be a plane figure, meaning it's flat. We're not talking about three-dimensional stuff here. So everything you're doing is still flat. Would you calm down over there? I know you're squirting water all over the place. Don't do that. Yeah. I know. So to create an actual polygon, you have to have at least three sides, meaning that you've got three segments that are going to be intersecting each other. However, as it says there, you can't have a common endpoint that are collinear, meaning that I can't have three segments and two of them be collinear, because there's no way I'm going to be able to create a shape if I've got a straight line and then another segment cutting down off to the side somewhere. So all it's saying is I got to have three sides at least. I can't have anything less than that. There are names for polygons that are less than three sides, but that's like the whole theoretical realm that you guys don't have to deal with, so we don't go through that. This part right here is talking about the fact that you can only have each side intersect each other once. So you got one intersection point between each pair of segments that are creating that specific shape. Okay? So to take from the first part, this is identifying the fact that you're using segments, meaning no curved sides. This right here is saying that each segment is going to intersect each other once at their endpoints. Okay? So like I said, to oversimplify this, or not oversimplify, but just to simplify it. Number one, right, no curve. So nothing that looks like that with like a little right there. That wouldn't be a polygon. Okay? It would just be, I don't know, something. Some kind of shape. All right, so that's got a curved side. This one where it's saying it intersects each other at their endpoint means that if I looked at that shape as a whole, that would not be a polygon. There's one here. I understand there's a triangle there, but if I talk about the entire thing, including these extended points there, like as a whole, that thing is not a polygon, even though there is one here with just extended sides on. Okay? So this one means it has to stop at the endpoints for the shape that you're looking at. So if I stopped at that endpoint, again, I can classify that as a triangle. And you can't have anything that's curved. Even if it's like a little tiny, even if I made this like a little tiny, just whoop, right there, it still wouldn't be polygon. You have the little tiny curve on it, still counts. For naming this stuff, we talked about this a little bit with triangles in the past, but the endpoints for your segments there, those are all your vertices. So each one is a vertex, so vertex will always be where the sides come together. And each segment is considered a side. So the segments are the sides, the endpoints are the vertices. Just to, between the two words, like naming, remember saying what letters are on the vertices. Classifying would be by like how many sides there are, if it's convex, concave, regular, so on. So if I were to name this, you just pick a vertex to start at letter-wise and go around either clockwise or counterclockwise. It wouldn't matter. Like that one there, what letter should I start with? How about one that's up there? That would be amazing. P. All right. Should I go clockwise or counterclockwise? Clockwise is the first one I heard. Counterclockwise loses. So PQRST. And that's all you get. When you name it, guys, you just write the letters. No symbol in front, except for a triangle. Triangles have symbols. But for that shape there with 5 sides, you don't have to put a symbol with it. You just write the letters in order. And if it asks for another name, it's just, so if they had, let's say I had that problem and it said, give me 2 names for that shape. That would be one. Another one would be, just pick a different letter to start with. QRSTP. There's another name for it. Okay? All right, so if you look on 86, you got a nice little chart there to fill in. Okay? Yeah, it's got some of it in there for you. So you have to know, classification-wise, the names for 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12 sides. Okay? So in order, of course, your smallest one is the triangle, which should be in there. That shouldn't be a problem. Which ones did I give you? I give you some of the other ones. All right, so 4 sides. Now these are general names. What is it? No. Okay, quadrilateral would be what you name here. So you want the most general name. If you, like a trapezoid is a type of quadrilateral. A square is a type of quadrilateral. Okay? Those are more specific names because they give specific properties. So in general, quadrilateral is what you need for 4 sides. 5 sides, right, is the pentagon, which they had in there, right? 6 is blank. What's 6? So hexagon. 7 they have in there. They have heptagon, correct? They didn't change the name on me there. 8 sides, right, would be octagon. 9 sides is a nonagon. All right, then look, after this, once you get to like 10, which is decagon, what kind of happens is for the next few, like if we were to go beyond 12, like into 13, 14, 15, you're taking the prefix for like the 5 sides and the 6 sides and attaching it to like the decagon part. Now for 11 that's in there, I'm going to give you 2 different names because it can be referenced as either one. I think they have the hendecagon in there. Undecagon also works. Because again, like the way these are set up is, like if I did the un would mean like 1, so it's like 1 plus a decagon, which is 10, so that's how you're getting the 11. And the 12, which they have 12 written out in there, yes? Yeah, so 12 being a dodecagon, right? Do is meaning add 2 to the 10 that's already there, that's how you're getting to the 12. Okay? All right, anything outside of this, if they want to let you know how many sides there are, what you'll see is they'll put the number of sides and they'll just write gon at the end of it. Like if I wanted you to work with a 30-sided polygon, I would just write 30 gon. Those need to be referenced by name. Anything besides that, you can write that way. Okay? So if it's like 15 sides, you just write 15 gon. Okay? All right, other classifications you guys need. Convex, concave. It's probably somewhere in there. Okay? So they got like words with it. By definition, what do they have in there for that? There's no angles, whatever. Look, if it's concave, do you guys know what concave looks like? Like what? It's got pushed in. Someone caved the side in, right? That's all it is. Okay? Like I said, it's always like someone punched or kicked the shape, so you caved in a part of it. Convex is the one that's not concave. So if you remember what concave looks like, and it doesn't look concave, it has to be convex. So convex is all of your endpoints are like pointing out. If you have any part that's pointing in, it's concave. Even if it's like a little tiny part. Guys, back there, knock it off. Trisha, knock it off, guys. Knock it off. Okay? So even if I took, if I wanted to make a concave shape, Like I said, even if I took it and I just went like that, it's still considered concave. Okay? Also, even if it's a little tiny part, it still counts as a side. So if I wanted to classify this thing right here, there's 1, 2, 3, 4, 5, 6 sides. And 2 of the sides point to the inside, so that thing would be a concave hexagon. So you're going to have to add to that chart that's in there. All right, the first one is equilateral. Okay, so equilateral means that all of the sides are the same length. So something like that. That would be an equilateral convex hexagon. The angle measures do not have to be the same, right? Because if I looked at it, I can tell that's an acute angle, that's an obtuse angle, so the angles are definitely not the same. All right, it's just saying that all of the side lengths have the exact same measurement. Then, if I switch that up a little bit, and I gave you one that had just all the angles being the same, then it's considered equiangular. So that just, if I see this word, right, anytime you see equal in here, that always means the same. Obviously, angular would stand for angle, so that means that all of these angle measures have the exact same value. Then if you take those two and combine them, you get the word that's on the top of your little chart there, right, which would be regular. So regular would be a shape that is equilateral and equiangular at the same time. So regular means all the sides are the same, all the angles are the same. Right? But not that the angle inside are not the exact same measure. That's not going to work. Could happen, but that doesn't always happen. All right, and then I don't have a picture for the one at the bottom, but then you got the irregular. Irregular is like everything is just a different measurement. Like all the sides are a different measurement, all the angles are a different measurement. On this one, so you do these. It's not in the book, okay? You can draw them out if you want, but you don't need to. But I want you to go ahead and classify by the number of sides if it's a polygon. Classify it with convex or concave. And then also if it is regular, irregular, so on. Which obviously there's nothing marked congruent, so the equilaterals and the irregulars and stuff should not apply. Hopefully this was a big fat no. No, yeah, you agree there? Okay. This side, if you count it out, this is it's concave. That was a dodecagon. 12 sides there, right? There's 3 in each little cross part. If you count these up, I think these were decagon here. It's convex because everything is pointing out. This one, again, is convex. And that's your quadrilateral. And then over here, this is a concave hexagon.